Welcome back. In the previous part, we ended by declaring and initializing several essential local variables in the hull entry function. These included an FSB status variable, a USB event info variable, a USB PCDC line coding variable, and an integer array for buffering. Following this setup, we called the OpenUSB channel API from the Developer's Assistance Toolkit and used an assert macro to ensure the call was executed successfully. With these preparations in place, we proceeded to construct the while loop. The first function in the while loop is the API to get the USB event, and it will populate the variables USB event and event info. A small delay is added to ensure the previous call has been completed. Now, we are going to have a switch case statement based on the USB event that has been captured. It is a slightly long code block, so let's begin. The first event type is USB status configured. For this case, we will call in the USB read API and store the data in the buffer we had declared earlier. The data size is 8 bytes and the destination is class USB PCDC. Alright, the next case would be for USB status read complete. When this event occurs, we would want to extract the data that was received by the USB. So, we start with an if condition based on the USB attach variable. Then, we're going to call the USB read API and store the data in a buffer with the size as 8 bytes and destination class USB PCDC. Now, we are going to read the received buffer. So, in order to execute some simple commands based on the received data, which is essentially the input from the user in the terminal, we will construct another switch case statement. We are expecting one specific case, which is the value of 1 from keyboard, and it should execute the print to console function to produce the string stored in key_1 variable. For the default case, that is any other key pressed, we shall display on the console some default string which is stored as key_other. We shall end this switch case statement as well as the case statement for USB status read complete, and we will move to the next case, which is USB status request. For this case, we are going to have a few API calls under if-else conditions. The first would be the USB PCDC set line coding. If the value from this macro becomes true due to the values of USB request type and USB request macro, we are going to call an API USB peri control data get. Remember, this is the gate API. The arguments shall be the G line coding buffer and the length specified in the line coding length macro. We will also allow some time for the API to execute using the software delay function. For the next condition under else if, we shall check for USB PCDC get line coding status and insert the USB peri control data set API and construct a similar structure as before. Just to recap, the RBSP software delay function is defined in the BSP delay file, which generates a delay in the program utilizing a clock source. Moving on to the next condition under else if, the condition variable will be the set control line state. When this variable is true, USB peri control status set API is called. As an argument to this API, we shall use the USB setup status ACK macro and we will add the software delay. The else condition does not need to have any operations and we can leave it empty. And that ends the USB status request case, which started in line 154. The next two cases will be the USB status detach and USB status suspend. For both these cases, we shall set the USB attach variable to false and clear the memory buffer by setting 0 values. For the USB status resume case, we shall set the USB attach value to true, and then the default case should only have the break statement. So that concludes the USB event switch case statement, which started in line 107. We shall now check whether all the loops and conditions are properly closed. So we will see where the closing bracket for the while loop is. As it turns out, there are two extra brackets that have been entered during our coding, so we shall remove them. Now let's try to build our program. Okay, there seems to be an error. Let's try to find out. Okay, we have mistyped the status error variable name. We shall change it back to the defined variable name. Let's rebuild. Alright, problem solved. Now, we shall upload our program to the device by selecting the debug option. Once uploaded and the main function is shown in the IDE, press resume button twice and the program shall start running on the board. Open the TerraTerm terminal and select serial.com. You will notice there is a USB serial.com device detected, which is nice and looks like the USB port of the array device. We will select it and press OK. That should ideally connect to the terminal to the USB port of our array device and respond to its requests. Let's try pressing 1. Okay, there you go. We can see the text being printed on the screen. Now, let's press a different button. We can see a new text when we press a different button. Press 1 again and press other keys. That looks very responsive. So, we can say that our program is able to acquire the input key press from the keyboard and then send back a relevant text based on the input. In our case, we have a defined text for key 1 and a different text for any other key on the keyboard. It's a bit of a long procedure to get this set up, but once done, you can have communications between the PC and array board via the onboard USB port.